problems we will face living on Titan. Welcome to a journey beyond our planet Earth. Today we embark on a cosmic exploration of Titan, the largest moon of Saturn. This celestial marvel, wrapped in an amber haze, calls us to explore its alien landscapes and consider the audacious dream of making it a second home for humanity. But just like any big dream, it's not going to be easy. We've got a lot of work to do before Titan can be like a second Earth. In this video, we will talk about the tough stuff people would have to deal with if they want to live there. Are you ready for the adventure? Titan. Description. For those among you who don't know what Titan is exactly, here's a brief description. Feel free to skip this part if you're already a pro. Titan, the second largest moon in our solar system, surpasses the size of the planet Mercury. Only Jupiter's moon Ganymede outshines Titan, but only by a slight margin of approximately 2%. Although Titan's atmosphere shares similarities with Earth's, consisting mostly of nitrogen, its surface experiences a pressure that exceeds our planet by 50%. Within Titan's surroundings, one can find a captivating array of clouds, rainfall, rivers, lakes, and even vast seas composed of liquid hydrocarbons such as methane and ethane. These remarkable seas boast depths of hundreds of feet and stretch across hundreds of miles. Beneath the moon's thick layer of water ice lies yet another astounding discovery, an ocean primarily composed of water rather than methane. This subsurface water could potentially serve as a sanctuary for life forms as we currently understand. Furthermore, the lakes and seas containing liquid hydrocarbons might enable the existence of life that operates on an alternative chemical basis, one that remains largely unfamiliar to us. Conversely, Titan could very well be barren and devoid of any signs of life. Well, settling on Titan might not sound too bad. I mean, it's not the worst spot in our solar system, right? But there's a catch. The first hurdle for humans would be dealing with Titan's environment. The landscapes there are quite different from the stunning views we're used to on Earth. However, Titan has its way of taking your breath away, quite literally. First problem, the Titan environment. You see, Titan's air is thick and mostly made of nitrogen, with a bit of methane and ethane mixed in. Just to give you an idea, if we stood on Titan's surface, the air pressure would be over 50% higher than what we're used to on Earth. It would feel like being underwater about 50 feet deep. So taking a breath on Titan might be a bit challenging. In the search for solutions, scientists are exploring the concept of terraforming, a process that involves modifying a celestial body to make it more Earth-like. To enable humans to breathe on Titan, we would need to introduce a significant amount of oxygen into its atmosphere. The challenge lies in the colossal amount of this element required. Picture this. To match Earth's atmospheric composition, we would need to release about 20 times the amount of oxygen ever produced in human history into Titan's atmosphere. It's a task of astronomical proportions. While terraforming Titan's atmosphere seems like a daunting task, there are alternative solutions to consider. Advanced life support systems, reminiscent of what we see in science fiction, could provide a controlled environment for human settlement. Picture habitats equipped with advanced air purification systems, ensure a constant supply of breathable air. These life support systems could act as our artificial lungs, making Titan's inhospitable atmosphere a more manageable challenge. Another approach involves adapting our methods for survival. Titan settlers could wear specially designed spacesuits equipped with advanced life support technologies. This would act as personal habitats, shielding humans from the harsh conditions outside. Additionally, constructing enclosed habitats on Titan's surface, resembling futuristic domes, could create habitable zones where the environment is controlled and suitable for human life. An integral aspect of sustaining life is the production of oxygen. While Titan's atmosphere lacks oxygen, it does contain water ice. Scientists are exploring methods to extract oxygen from this ice through processes like electrolysis. Picture future settlers establishing facilities to harvest and extract oxygen from Titan's abundant water resources. While the solution is still in the realm of theoretical exploration, it represents a potential step towards self-sufficiency. As we navigate the challenges of Titan's atmosphere, the key lies in adaptability and innovation. While breathing the air on Titan may seem like an elusive dream today, the relentless pursuit of knowledge and technological advancement might one day turn this dream into a reality. Second problem, the Titan climate. But it's not just the lack of oxygen. Titan's climate poses another challenge. The average surface temperature hovers around minus 290 degrees Fahrenheit or minus 179 degrees Celsius. To grasp the severity of this cold, let's compare it to the Earth's coldest recorded temperature, a mere minus 140 degrees Fahrenheit or minus 60 degrees Celsius in Antarctica. This makes survival on Titan a chilling endeavor. Suits specially designed to withstand Titan's extreme cold, a high-tech ensemble that combines insulating materials and advanced fabrics, could be a solution. Scientists are researching and developing apparel that provides exceptional thermal insulation. Such suits must be layered with materials capable of trapping body heat while resisting the penetrating cold of Titan's surface. Flexible fiber-reinforced aerogel composites are currently being studied for use as insulation materials for a future spacesuit for Moon and Mars exploration. This material has a high flexibility and good thermal insulation in both high and low vacuum conditions, making it a promising insulation candidate for the spacesuit application. These spacesuits are currently being developed at the Johnson Space Center. Additionally, spacesuits could feature built-in heating elements, ensuring that astronauts remain warm and functional during their exploration on Titan's frozen landscape. Another solution could be to create underground habitats on Titan burrowed beneath the icy surface. Similar to Earth's cozy underground dwellings, these habitats would provide natural insulation, shielding settlers from harsh external temperatures. Imagine a network of subterranean tunnels and chambers where humans can thrive in a controlled and temperature-regulated environment. That would be amazing, no? Hey, before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Third problem, limited power. Next on our list is the issue of energy. On Earth, we harness the power of the sun for solar energy, but Titan, located 10 times farther from the sun than Earth, receives only about 1% of the sunlight we're accustomed to. A solar panel on Titan is like a flashlight in a dimly lit room. It doesn't provide the energy needed for a thriving settlement. One solution obviously relies on nuclear power. Nuclear reactors, similar to those used on Earth, could provide a reliable and consistent energy supply. Humans could build settlements powered by compact and efficient nuclear reactors, generating electricity to meet the demands of everyday life. This approach offers a robust solution, independent of solar fluctuations and capable of sustaining a growing population on Titan. Another less common solution could be the use of RTGs, radioisotope thermoelectric generators. RTGs convert the heat produced by the radioactive decay of isotopes into electricity. RTGs convert the heat produced by the radioactive decay of isotopes into electricity. We could strategically place them throughout Titan's landscape so as to provide a constant and reliable energy supply for both manned missions and potential settlements. This technology has already proven successful in powering various spacecraft, showcasing its durability and efficiency. But we could also use Titan's vast reservoirs of methane themselves as an energy source. This element could be harvested and utilized as a fuel for power generation. We would only need time for advanced technologies to appear to efficiently extract and refine methane, turning it into a clean-burning fuel. This approach would not only provide an energy solution, but also leverage the local resources available on Titan. And being even smarter, it's worth exploring the potential of harnessing Titan's strong winds. These are particularly strong at high altitudes. Perhaps we could tower wind turbines stretching into the hazy skies, capturing the energy from Titan's atmospheric currents. This approach would provide a renewable and sustainable source of power, utilizing the natural forces that shape Titan's dynamic climate. Last but not least, we could extract some energy from Titan's lakes and seas through tidal power. Yes, you heard me right. The gravitational forces of Saturn's tug on Titan creates tides in its liquid methane and ethane bodies. Placing underwater turbines in these lakes will turn out to be a very effective way to convert the energy from tidal movements into electricity. Smart, huh? Fourth problem, scarce water resources. Water, the elixir of life on Earth, presents another hurdle on Titan. Though there are indications of liquid water beneath the icy surface, it's not readily accessible. On Earth, we take for granted the abundance of water, with vast oceans covering over 70% of our planet. Titan, on the other hand, offers only small lakes and rivers, equivalent to a drop in the ocean of Earth's water supply. A first solution could be the mining of ice on Titan to extract the precious water it contains. Ice mining could then become a vital activity for sustaining a human presence. Would you like to work as an ice miner on this moon? Let us know in the comments below. Then later on, we could build robots or missions harvesting ice from Titan's surface or subsurface, creating a Titan aquifer that serves as a valuable water resource for settlers. Not only that, Titan might be holding secrets from us. Everything we know about this moon, we know it because some probes flew by it. But imagine a scenario where settlers step foot on this moon and tap into Titan's subsurface for water through hydrothermal exploration. Just like Earth, Titan might harbor subsurface reservoirs heated by internal processes. New drilling technologies designed for Titan's icy crust might be envisioned, reaching these potential reservoirs and extracting water. This approach could open up vast reserves of water beneath the surface, ensuring a long-term and sustainable water supply. Then, given that our technology is good enough, we could consider the possibility of importing water resources to Titan from outer moons or asteroids within the Saturnian system. Imagine thousands of cargo spacecraft laden with water ice making regular journeys to Titan. While this might be a logistical challenge, it could serve as a supplement to locally sourced water, ensuring a more abundant and diverse water source for settlers. Of course, water could also be recycled, perhaps in a similar way it is already done on the ISS. We would need settlements equipped with sophisticated water purification and recycling technologies, but in principle, every drop of water from human waste to industrial runoff can be meticulously processed and reused. This closed-loop system could significantly reduce the dependence on external water sources, creating a self-sufficient water cycle on Titan. Fifth problem: communication lag. As we look to establish a human presence on Titan, one of the significant challenges that arises is communication. The vast distance between Titan and Earth introduces a communication lag, reshaping the way we connect across the cosmic expanse. So how do we navigate this time-delayed conversation and maintain a link with our home planet? One of the simplest solutions would be to set up a network of communication satellites orbiting Titan, serving as real-time data relays. These satellites could act as intermediaries, receiving signals from Earth and transmitting them with minimal delay to the Titan settlement. These satellites would certainly be the reminders of our home planet Earth, bridging the gap between the two celestial bodies. We could also make use of a communication strategy that involves pre-recorded messages and scheduled updates. Settlers on Titan could record messages during optimal communication windows and schedule their transmission to Earth, pretty much like we do today with emails or WhatsApp messages. With enough careful planning and coordination, we could set up a system where important information, updates, and personal messages are sent at specific intervals, mitigating the impact of the communication lag. And of course, let's not forget that in the future, AI will become more and more powerful. We could envision advanced artificial intelligence systems managing communication on Titan. These assisted systems could predict and simulate conversations, compensating for the time delay. It seems a sci-fi scenario, but AI algorithms could indeed analyze patterns of communication, ensuring a seamless and coherent exchange of information despite the delay. This intelligent communication infrastructure could become a vital component of future Titan settlements. Would you trust it? What's better, Mars or Titan? As we discussed in one of our last videos, the main issue with Titan is the tremendous distance from us, it being roughly 1 billion miles from Earth. That would mean a journey of at least 7 years. To put things in perspective, reaching Mars only takes about 7 months, making it a much more practical and easier option. In other words, Titan is a long-haul destination, but it could yet prove the most alluring both for humans to visit and for the search for extraterrestrial life. Another key factor to consider would be the magnetic field. Mars has patchy magnetic fields due to its ancient crustal magnetism. While not globally protective, these magnetic fields may provide localized shielding from solar wind and cosmic radiation. Titan, on the other hand, lacks a significant global magnetic field, which means it doesn't provide the same level of protection against solar wind and cosmic radiation as Mars potentially does. Ultimately, both Mars and Titan present unique challenges and opportunities. Mars offers a more Earth-like environment in terms of day-night cycles and potential surface habitats, and its proximity allows for shorter travel times. On the other hand, Titan's harsh conditions and distance make settlement more challenging, but its intriguing atmosphere and unique features like hydrocarbon seas may offer scientific and resource utilization opportunities. As we conclude our journey into the challenges of living on Titan, we must acknowledge the enormity of the obstacles that await us. Titan, while a captivating celestial body, presents an environment vastly different from our home planet. From extreme temperatures to limited resources, settlers would face a formidable frontier. Yet, in the face of these challenges, the human spirit for exploration and adaptability might find a way to make Titan a new home in the distant future. That's all for this video. Thanks for watching. Do you think we will be able to eventually step foot on Titan? Let us know in the comments below. We'll see you next time on the channel.